So my name is Petr. I'm from Czech Republic, Masaryk University, and this is the joint work also with the people from Turing Institute in the UK. And just to calibrate, I would like to ask you how many of you heard about the CoinJoin before? The CoinJoin technique. Okay, that's the third. So this is something that is really used in practice for a long time. People mixed more than 400,000 bitcoins. That's roughly 25 billion dollars worth of bitcoins over the time. So this is something that is really used. But I feel, or we felt that it's understudied. So we took a look on that. So when you are paying someone on a Bitcoin network, you are creating a transaction. You have some coins. These are on the left side of the input, and then the payment turns out to be coins on the right side that are created. They are outputs, and you are the owner of the left side. And typically, if you have the coin that is bigger than what you want to spend, you have some left over. Okay, so this is stuff that is coming back to you. But then you are paying someone, maybe just a little sliver. And these transactions are recorded forever in the blockchain. And also, if you are the guy who is paid, you somehow know from whom you are getting the money typically. Like if you are selling your car or selling your coffee to them, you know, okay, this is the guy who paid me. And this is the first problem because the guy can see, okay, I got this small sliver, but a lot of bitcoins get back to the original user, and maybe I will go and rob them. So that's one thing. Another problem is if you are donating, let's say to the Navalny Foundation, then the Russian government might be interested in figure out who was the one donating and then go after them. And that really happened. Maybe for a specific transaction, you are able to somehow delink your real identity from that transaction, but you can screw up later because these transactions are creating large graph, and maybe you can later on consolidate your coins, and this way you will basically, for the observer, for the attacker, label the inputs, and the attacker will later learn his back. Okay, so that's a problem. What to do with that? So one option, or one technique, typically these analysis companies are doing, is that they are assuming that all inputs are from one user, and this is the basic heuristic they are using. So let's break this heuristic, and this is what the CoinJoin is doing. They will get a bunch of people together. They will together create one single transaction in a way that is then harder for the observer to analyze. Okay, so this is one of the typical CoinJoin transactions. You can take a look that the outputs are all exactly the same. That's on purpose. So even if you know who owns the inputs, you then don't know who exactly owns the particle output. Okay, and this one is specifically from Samurai Whirlpool, which was the CoinJoin protocol design as well as implementation running for a long time. And we can also guess that roughly or likely there are 5 users here. These CoinJoins do have different designs. So you can have a design which is instead going for a very large number of inputs and outputs in order of hundreds. This idea is not new. This is here for a long time, and the main goal is if the observer is seeing a transaction, the assumption, the ethical model is they know who owns the input, how to make it so that they don't know who owns the output, specific output. Okay, so the CoinJoin transaction is not meant to pay someone; it's meant to return the money back to you, but in a way that will make it hard for the observer to attribute the outputs to you. Okay, so that's the idea. And the reason why it works is because there are many options how you can get the money back. Okay, for these specific 3 cases, you can get your money back in this direction or this direction, and maybe you don't know as an observer completely who owns the inputs, so it can be the different composition. So even for this simple example, there are 24 options how to create these packets. And this all contributes to the resulting anonymity of your financial transaction, but there are more anonymity factors than just the number of users. So number of users, number of mappings, also how many same value outputs you have, also how many times you will repeat this thing, because you can go through multiple transactions. You just don't need to stop after that. What can also decrease the anonymity is how the other users are behaving. So if everyone else than you will adopt their identity, then okay, you are out of luck. You are no longer having any problem. So just to give you the insight into the ecosystem, this paper is not about the join market, which is one design, but this is really like OG protocol, which is started in 2015. It's running since then. Okay, so this that's there. We more focus on the protocols that have a centralized coordinator, but where the coordinator comes through. Wasabi one is the protocol designed by the company called Hicks. They also went the operation of this coordinator, and they started 2018, stopped 2023. And the reason why they stopped, they don't have the better protocol, so they just run out, just roll out the better protocol. Then there was a different design. You already see one transaction, Whirlpool. That one was stopped as well, but fortunately by FBI they seized the service. Maybe you heard about that case. Based on that, the secrecy company decided, hey, this seems to be too hot at the moment. We are no longer going to operate the coordinator, but other people did. Okay, so they just took the open source software, and there were many coordinators, and they did it. And at some point in time, Whirlpool under the new coordinator also resumed. Okay, so that's the situation. And we had the three basic questions. The first one was like, overall, how many bitcoins are mixed, how many transactions, like get some insights. That's one thing. The second thing is, can we see the behavior of particular users while they are mixing, especially if they are big users? That's a lot of people. And the third one was, can we identify coordinators that are not publicly known? Like retrospectively looking at the data, can we see someone would know? Okay, so how do we approach that? There is a blockchain, everyone can download it forever. Basically, there are coordinators run by this, there are designs run by the coordinators, and we are first contacting in real time these coordinators and getting real time data. So that's one thing, one data set. The second one, we also run our own wallets that were participating in the CoinJoin. It was a little bit expensive, but we got the guarantees from the side of people that really participate in the CoinJoins. And then we did a lot of processing, and the paper is about the algorithms, how to analyze this, how to get the results. So let's take a look at some results. First of all, can we identify the past coordinators, maybe even unknown ones? So if you can identify joint transactions, so this is roughly for specific design 100 transactions per day. If you don't have any additional information, you don't know who is the coordinating party, but because you can actively monitor these known coordinators, you can start to learn what are they. Okay, and you have the difference between the unknown transactions and the transactions you can attribute. And based on this, we figure out that there are 11 coordinators plus 2 additional unknowns. You can then later on analyze the clustering and stuff like that. So that's one thing. The second thing is an important question is how many users are actually participating. And for this, what we used was the fact that we participated in a large number of CoinJoins. We got the, let's say, behavior statistics about our wallet and what we saw there, and then we extrapolated to the whole CoinJoin, and then we predicted the number of users. So for one specific design, it was 72, and then the ZK stack coordinator, we roughly estimated it was like 60 users at the time. After this one was closed and the new ones were started, this is the situation right now for the biggest one, which is proof, and there are roughly 70 mixing users. What we don't know though is whether they are real users or symbols. Okay, that's another and also open question how to detect symbols in this epic. And the final part is whether we can see the behavior of large users. By large users, I mean someone mixing more, significantly more than the other people, and we designed algorithms and visualizations how to detect. So these spikes and then going down, this is the you observing some like bigger whale mixing the funds, and different designs, different behavior. This can help you to also predict what is the reality there. Overall, we also then, after all these analysis, we can tell you how much was mixed, when, what are the trends. So we have some graphs for that. If you're interested, come to the poster. Different designs are exhibiting different properties. So if you like to learn more, just visit the QR code where we have our stuff together, and also visit the poster. So sure. Thanks very much.